Hi again, welcome to the video outlining the calculation of the area of a trapezium. Our emphasis here is not on what the formula is. I hate formulas, I forget them. Instead, it is in the concept of what we are doing. In everyday life, the area of a trapezium is calculated in various contexts, so it's important to understand the fundamental concept. The trapezium is a happy little figure. It's a member of the quadrilateral family. All members of that family have four sides. The trapezium is often referred to as a trapezoid, and it has one pair of opposite sides parallel. We need to be able to calculate the area of a trapezium in both plane shapes, just like we see here, or in composite shapes when we might have a circle or a triangle added to it. We need to be able to do calculations of trapezium in all sorts of situations. They can be found in survey diagrams, they can be imposed on maps. Often they're going to be found in photographs of all kinds of objects, tables, buildings and so forth. And they're also in objects in the world around us, like fancy swimming pools, curvy verandas, gardens, beautiful rocks and so forth. To start describing how to get the area of a trapezium, we need a few dimensions. So I'm saying the top side is length A, the bottom side is length B, and the distance between them is h. Now what we do is to go halfway up the left-hand side, and with our scissors we just cut off the bottom triangle, and then we slowly move it around until we can put it into the top part, and where it will fit exactly because we went to the middle of that side, and in it goes. We then go to the right hand side, out with our scissors, go to the point halfway up the slopey right hand side, cut the triangle off, turn it around, bring it up, and in that one goes too. So now we've actually produced a rectangle from our original trapezium. And the top and lower sides of the rectangle are made up from the top and lower sides of the trapezium. No more and no less. Now the rectangle has opposite sides that are equal, and so the size of each horizontal side in our figure we have now is A plus B over 2. Now the area of the rectangle therefore is A plus B over 2 times h, which is the distance between the parallel sides. So therefore the area of the trapezium can now be expressed as half of the sum of the parallel sides of the trapezium times the distance between them. Now we understand how to calculate the area of the trapezium, and so we can do an example. What is the area enclosed by the trapezium I've shown here? You notice its top side is 6 centimetres, its lower side is 10 centimetres, and there's 3 centimetres between them. Well, the area, as we can note down the bottom, is the sum of the parallel sides, which is 6 and 10, so 6 plus 10, divided by 2, times the distance between them, which is 3. So that puts in your calculator, or you do it in your head, 12 centimetres squared. Now we can do a second example. The area of this beautiful blue-topped trapezoidal shaped tabletop is 0.81 metres squared. The rear edge of the table is 1500 millimetres long. See, typical maths teacher, always mixing up the units to make it hard for us. The table is 720 millimetres wide. So, question. How long is the front edge of the table? We'll call it L for now. The first step in trying to find out how long the front edge is to overcome our problem of the mixing up of millimetres and metres. Well, stick to the metres, because converting from metres squared to millimetres has got too many zeros, so we won't try to make it hard for ourselves. We'll stick to metres. So we can write 0.81 is equal to the sum of the parallel sides. The first one is 1500 mils, which converts to 1.5 metres, plus the L for the length of the front side, which we're trying to find, divided by 2, times the distance between those parallel sides, which is 720 millimetres divided by 1,000, so it's 0.72. Get rid of your fraction, multiply both sides by 2, and then convert from there. You're going to find that L is equal to 0.75 metres, which will now convert back again to 750 millimetres. Our third example shows the trapezoidal entrance to a very lovely house. The total area of the trapezium for the entrance foyer is 8 metres squared. The top edge is 2.8 metres wide, while the bottom edge is 5.12 metres wide. The question is, how high is the entrance? Well, we know the area is 8 metres squared. 8 equals the sum of the parallel sides, 2.8 plus 5.12, all divided by 2, times the distance between them, which we can call h. Put all that into your calculator and h turns out to be 2.02 metres or 2,020 millimetres. So there it is. The approach to calculating the area of a trapezium can be developed by cutting off the end triangles and placing them at the top to form a rectangle. Then we can find the area of a trapezium by simply adding the two parallel sides together, dividing them by 2 and multiplying by the distance between them. There are 4 components we have to consider, so all questions will give you 3 of these and then ask you to find the 4th. See, we're ahead. To consolidate your learning, do the exercises in Test Yourself 1 on my website, drjaysmaths.com. Thanks for watching this video. Hit the like button and subscribe if you haven't already. Add a comment or send me an email if you have any questions. Good luck. See you later.